back side here is rooms. The panels will go up over the roof of it, but there's a feed storage room on the end for the fish, and then there's a workshop where we can carve all the doors and stuff for the house and the window covers. And then on the end is the powerhouse for the inverters, batteries. There's some more combiner boxes. I ordered, I need 4 combiner boxes for the array out here. They're 4 in, 2 out. Reason being, if I want to fine tune the fuses, I need 2 circuits, 2 in, 2 out. But once you're into buying, you've already bought the box and paying the shipping on the box, and the lighting protection's in there, and the circuit breaker's in there. The difference between a 4 in, 2 out and a 2 in, 2 out is a couple of fuse holders. But I can put in 2 fuses on a line, and if I wanted to turn that thing to say 17 amps input or 13 amps input, I can put a 10 amp fuse in and the smaller fuse right beside it, and the smaller one will blow first, so it'll actually give you a little more safety. Anyway, I made a couple changes. I had these manufactured in China, but I got 4 of them for the array out here, and then I got a second 4. Once they're set up to make something over there, it's an assembly line. I made a change on the boxes also. I decided I want stainless steel. The average box you get, there's 2 kinds. It's plastic and the option is galvanized. And I think the galvanized, it's pre-galvanized, so they have the cut edges. Galvanized protects itself electrolytically or so around the edges, so it won't rust those edges even though it's raw steel. But I just thought I'd rather have stainless. So I paid $44 a box more to get it made out of stainless steel. We're not going to fool around with this solar system. We're going to do it just as nice as we can. I was sitting there looking at that $352 or whatever it was to make them into stainless. I said, well, just go ahead and make them out of stainless. I must have wanted to do it or wouldn't ask on that option if they could do it. Anyway, so you have 8 strings is 7 panels, is 56 panels. We're buying 62, 2 flats of them, 2 pallets of them. So the other ones are going to be running a well pump. We're going to mount them up on the roof of this powerhouse and just run the wire over to the well pump. But I want a drinking water well. The one that Benji's dad and brother put together is a drinking water well. The people that lived on this property for the last 100 years have been drinking water right off the property. This second set of combiner boxes, when the power comes in out of the first one's inside the power room, I'm going to run to another combiner box. It'll also be MC4 connectors, DC. It gives me a second string of lightning protection, a second string of fuses. I can have a different amperage of fuses on one thing or the other, and the lowest one's the one that'll blow. Also, say I have 2 inverters, and I have 2 strings of PV power to put into the 2 inverters. What I decided to do is I'll take 1 string and I'll put a Y splitter on it, and I'll run that string into the left channel of 2 inverters. And I'll take the other one, I'll split it and put it onto the right side of 2 inverters. And this is gonna it's got advantages on the number of amps going into an inverter, and when clouds and shadows and stuff, goes across the array. Some are on, some are making power, some aren't making power. So I got about 4 reasons why I'm going to try that trick. I haven't tried it with any electrical engineer and see what they think of it, but I'm going to do it anyway. We have 3 inverters intended to charge batteries, and that's to run all the pumps at the circulation pumps, filter pumps, etc., on the on the fish tanks, and also their Venturi air for aeration of the water. And there's a side branch that's going to go up here on top of this roof up here, and we're going to grow vegetables in gravel up here. With it's part of the filtration system. That bacteria helps clean the water, and the plants take out the nitrates. It will come up here. There'll be some ammonia in the water when it gets there, and the first section will turn ammonia into nitrites. And there's a second bacteria that occurs naturally. It'll turn it into nitrates, and then it goes through the vegetables. And that turns it back into pretty much plain water. Not that I would want to drink it, but it's probably safe to drink at that point. It's a biofilter. And the salt has been taken out down there at bulk containers. There's a auto siphon that pulls the water out of the bottom of the one end. The aeration water that runs it, those fan out down across the bottom of the tank in series, and they sweep the tank continuously. And then this solid lifting device, that's a pipe. It goes near the bottom. We got a plate on it to make it pick up a wider area, but it's just a pipe. It goes up and goes out through the side of the tank. And where it goes through, it's got a T going up that draws air. If the water level goes below the siphon level, then it stops taking water out. It's simple as dirt. Anyway, that goes into a radial flow separator. That's an IBC, intermediate bulk container, the big square thing with the metal grid box around the outside. It goes down, makes it a 180-degree turn, comes up, and every time it goes up or down, the area of the water column gets like 2.5 or 3 times bigger. So what you're doing is slowing the water down. And the last time it turns down there, it's moving so awful slow compared to what it is coming in that all the solids can't make the turn to go back up, and they just end up on the bottom. And every once in a while you open a drain on the bottom and dump some water in the solids. Fish poo, uneaten feed, all that kind of stuff. How did I get on that? Oh, so we have to have plenty of batteries to run these 2.5 horsepower pumps. All of them are the same pump. All the tanks have the same pump. Then you have 4 inverters that take photovoltaic DC and turn into 230 AC. And you can use the AC just like it is. Like we can be running pumps off of that. If the pumps are AC. That you have to invert the battery power to run them. And any extra power on those 4 inverters is net metering back to the grid. So at night, the first priority is charge batteries, keep them topped off in case we have a power outage. And then the rest goes to running pumps and stuff. Those 4 inverters don't charge batteries. So we're going to make put a load on them. This basically is a charge controller, and we're going to take part of the output, and there's plenty of it, 33 kilowatts of PV going into this powerhouse. And we're going to run charge controllers. We're going to charge the batteries with a separate piece. A lot of systems use separate charge controllers. we were going to do all hybrid, but I couldn't get MPP Solar to ship. They wanted only what they call EXW trade terms, which means you have to pick it up at their factory in China and arrange all the paperwork and all the shipping and the cargo for sea freight. And it takes 2 forwarders, one in China and one in Manila, Philippines. And the chances of you ever seeing what you got is kind of slim on my point. And then we had a couple INVT, also a 5-year warranty. MPPT Solar was a 1-year warranty. But INVT, they had a 5-year warranty, but I could never get a price plus shipping. It just went around in circles with call our sales staff, and the sales staff gave you a lead back to the company, and they tend you to look for the sales staff. So I'm still waiting for a quote from November 20th of 2021. And they're still contacting me wanting to do a quote, but they just won't give me a price. And 4 or 5 other major brands, but you got originally a German company called Vectron, Vectron. They're still in business, but they manufacture their inverters now in China. And the 2 main brands is MPP Solar with the 1-year warranty and GrowWatt. It's the largest inverter manufacturer on the planet. They've made over 4 million inverters. So that's a lot of pieces. Do you think there's not 4,000 or 4 million solar things in the world? But it takes a lot more than one inverter. Like we're having 7 on this little array here. If this was a gigawatt facility that covered 2 or 3 hectares, then you might have 70 inverters. So they use them in great quantities, is why they make so many. Anyway, they got a 5-year warranty, and they were the first ones that gave me a promise of shipping it to Manila to a bonded warehouse. I got to pick them up there, but I think they changed it because the shipping was getting hard for their forwarder. Couldn't find a place in a container that the stuff would fit that he could make a profit, and he was just dragging his feet. So they checked with UPS and decided they'd just put the difference in the bill just to get them sent. So I got a tracking number. It's eventually going to get here. There's going to be a video on buying the stuff that we actually bought. You have to negotiate on Alibaba. You don't just say, okay, I'll take it at that price, because the price listed on the ad is not what it sells for. That's just to get to put at the lowest price so that you will open their ad and read it. It's bait and switch, I guess. Anyway, that needs to be a separate video. And this video is about pouring concrete with what I call the Jamaican finish. Because that's about what it looks like if you look at a house building video in Jamaica. That's what the finished concrete looks like. I can't imagine. And they pour stairs and things with the same kind of crappy finish. I don't know what they're thinking. They seem to be bright enough people, and they're pretty good at rendering. They know how to straighten it up when they're done. But when you pour a floor like that, you can't put tile on that. You got to put what the old 1950s called a mud pack. It's like 2 inches of cement-rich mortar, and you put a bonding agent on the concrete. Then you put that down, and then you have a ABC or equivalent tile adhesive, and you back butter your tiles, and you put a slurry, a watered down version of the ABC on top of the mud pack. And then you press the tiles into it. There's a good chance you get a lot of air voids in that grid work on the back of the tile, which makes them come up, makes them crack. Biggest thing is that they crack when you walk on them. And if you're going to have a tile on a carport that you're going to park an actual like Toyota or something on it, it's just going to fall to pieces. It's just not. There's no hope for it. James Tanner, Villa Feliz, one of the best house building channels there is. Between him and Texas Filipino, they cover everything. He had to pull his tiles up twice on his parking space, which is under his house. It's in the finished space inside the basement. He put a basement under his house. But as particular as he is about everything, he had them come up twice, And All Home, it's a chain in the Philippines. They sell hardware, groceries. They have a bakery, tile. They've give up even trying to put tile back. They're pouring like mortar mix and finishing it. All the walkways around their aisles and stuff, the tiles are just falling all to pieces. And there's hundreds and hundreds of them that's broken. And this is a major mall. Nice building. Took them a year and a half to put it up. But the tile work just fell to pieces. So we're not going to do that. We're going to pour a self-leveling compound. You have to put the bonding agent in the self-leveling compound. And then we're just going to use a notch trowel and put tiles down like you do in the U.S. It's called thin set. It's not that they don't know how to do that in the Philippines. If you have your bathroom tiled, that's how they do it. They use thin set. They don't put mud pack on 2 inches thick on your bathroom or exterior work that's got tile on a vertical surface. They put it on like we do in the U.S. But when they come to floors, because they haven't finished the floor, it's really hard to try to put tiles down on an uneven surface. They've rendered the walls in concrete, made them absolutely flat. No skim coat, of course, but the render is flat. So you can do the tile on the vertical walls. Here we have one of those laser levels. Green light makes everything obvious when it's not flat. And we have a surveyor's transit, and we took a day, and we individually taught every last person on the crew whether they could understand any English. I had a translator, and we had them set it up and make measurements and move it and set it up and take back measurements and measure the difference between what they got and show them that it comes out no matter where you put it. And we showed them where you want to put it, in a corner or in the center of what you're doing, Showed them that the range is about 300 feet on our transit, so it would cover the entire build site. And when we go back to the States, they don't get it out anymore. They'll do it in front of me, like when we did the drainways lines, the gray water and black water lines. I wanted exactly a 1/4 inch to the foot. So if it's 100 feet and it's 100 quarters of an inch, you shoot a level line and then you move the transit so it lowers the far end by the 100 quarters. And then anything you look at all along the pipe, you're reading the same number. If the transit's set at 52 inches off the ground, then it'll read 52 all the way, and then you're exactly on grade. So we got all the pipes sitting up on little wood strips and what all kinds of garbage, and then we poured concrete around them to keep them there. But they use a water transit, and plastic tube with water in it, and a guy on each end, and a measuring tape, and a felt